The layer of gases that surround the Earth, atmosphere. The atmosphere is a mix of gases like oxygen and nitrogen that surrounds our planet, protecting life and helping regulate temperature. Imagine trying to keep your coffee at the perfect temperature while sitting outdoors on a cool morning. Just as you might use a thermos to create a protective barrier between your coffee and the chilly air, the Earth's atmosphere acts as a shield to maintain a stable environment for life by trapping heat and blocking harmful solar radiation. The thermos and the atmosphere both serve as protective layers, preserving the internal conditions, temperature for your coffee, and climate stability for the Earth by controlling the exchange of energy with the outside world. Electromagnetic waves with wavelengths longer than that of red light. Infrared radiation. Infrared radiation is a type of light energy we cannot see, but we feel as heat. Imagine trying to find your favorite song on a long playlist by listening to each track one by one until you hear the right tune. This process is a bit like how infrared radiation works, as it involves energy waves with wavelengths longer than those of visible red light, extending beyond what we can see, similar to how your song is hidden among many others. Just as you scan through songs to find the right melody, infrared waves stretch beyond the visible spectrum, carrying energy that is felt as heat, not seen, but very much present in our daily lives. The second lowest layer of the atmosphere, it extends 15 to 50 kilometers above Earth. Stratosphere contains the ozone layer, which protects us from harmful sun radiation. Imagine trying to organize a messy closet where things are stacked in layers, with each layer serving a different purpose. The stratosphere is like the second layer of this closet, sitting just above the first layer, where everything is neatly arranged and categorized, spanning from 15 to 50 kilometers above the Earth's surface. Just as each layer in your closet might hold specific items like shoes or hats, the stratosphere holds specific atmospheric components and phenomena, such as the protective ozone layer, which is crucial for blocking harmful UV radiation. This organization helps maintain order, with each layer having distinct roles, much like how each layer of the atmosphere has distinct functions and characteristics. The layer of the atmosphere closest to Earth's surface, troposphere. The troposphere is where all the weather happens and where we live and breathe. Imagine trying to find your keys in a messy room where everything you need is always at arm's reach, but things tend to get cluttered and mixed up. The troposphere is similar to this because it's the closest layer of the atmosphere to Earth's surface, where all the weather activity and most of the air we breathe are concentrated, much like how daily essentials are scattered around your room, just as your room is the space where most of your day-to-day activities happen. The troposphere is the atmospheric layer where most of Earth's weather and life-supporting processes take place. Electromagnetic radiation with wavelengths shorter than visible light, it tans skin and can cause cancer. Ultraviolet radiation. Ultraviolet radiation is a type of light from the sun that is invisible to the eye and can cause skin damage. Imagine you're at a crowded concert, and despite being surrounded by people, you can't see the stage clearly. Ultraviolet radiation behaves similarly in that it's part of the electromagnetic spectrum that we can't see, just like the stage is hidden from view. Just as the crowd's density blocks your view, ultraviolet rays are shorter than visible light, slipping past the crowd of longer wavelengths, affecting your skin by tanning it, or even causing harm like skin cancer. The warming of the Earth when the atmosphere traps heat like a blanket. Greenhouse effect. It is a process where certain gases in Earth's atmosphere trap heat, keeping the planet warmer. Imagine trying to fall asleep on a hot summer night with a thick blanket covering you. Just as that blanket traps your body heat, making you feel warmer, Earth's atmosphere acts like a blanket by trapping the sun's heat. In this analogy, your body is the Earth's surface, the trapped heat is like the sun's radiation, and the blanket represents the gases in our atmosphere, which trap heat and warm the planet, illustrating the greenhouse effect. The effect of Earth's rotation on the direction of winds and current Coriolis effect. The Coriolis effect makes moving air and water turn and twist, causing winds in the northern hemisphere to deflect to the right and in the southern hemisphere to the left. Imagine you're trying to walk in a straight line on a spinning carousel, just like how you find yourself unintentionally veering off course due to the spinning platform beneath you. The Coriolis effect causes winds and ocean currents to curve as they move across the spinning Earth. In this analogy, the carousel represents the rotating Earth. Your intended straight path mirrors the intended straight line movement of winds and currents. And the unexpected curve in your path illustrates how Earth's rotation diverts these natural flows, creating the Coriolis effect. A band of high-speed wind between the troposphere and the stratosphere. Jet stream. Jet streams are fast-flowing air currents in the atmosphere that influence weather and climate patterns. Imagine you're trying to navigate through a crowded shopping mall on a busy weekend where people are moving at different speeds and directions. This situation is similar to how the jet stream operates, as it is a fast-moving band of wind that flows between the slower-moving layers of the troposphere and the stratosphere, much like trying to find a clear path amid the bustling crowd. Just as finding a fast-moving lane among shoppers can significantly speed up your journey through the mall, planes can utilize the jet stream to travel faster and more efficiently across long distances. Air movement caused by pressure differences. Wind. Wind is the movement of air from high-pressure areas to low-pressure areas. Imagine you're in a crowded room and someone opens a door to a quieter, less crowded hallway. This is similar to how wind works, because just like people naturally flow towards less crowded spaces, air moves from areas of high pressure to areas of low pressure. In both scenarios, the movement is driven by pressure differences. People are pushed by the discomfort of the crowd, while air is pushed by atmospheric pressure imbalances. The transfer of heat energy between two objects through direct contact. Conduction is when heat moves from one object to another by touching them together. Imagine you're trying to pass a secret note to a friend across the table without anyone noticing. Just like the note needs to be physically handed over to your friend for them to read it, heat energy transfers from one object to another through direct contact in conduction. In this analogy, your hands touching the note represent the objects in contact, and the secret message being passed from one person to another is like the heat energy moving from the warmer object to the cooler one. The transfer of heat energy from a warmer area to a cooler area in a liquid or gas. Convection. Convection is the process where warm air or liquid rises and cooler air or liquid sinks, creating a cycle. Imagine you're trying to cool down a hot cup of coffee by stirring it with a spoon. This is similar to how convection works, where movement within the coffee, like that of heat energy in a fluid, transfers heat from the warmer coffee to the cooler room air. Just as stirring the coffee helps distribute the heat more evenly and allows it to cool faster, convection involves the movement of warmer and cooler fluid particles, facilitating the transfer of heat energy from a warmer area to a cooler area in liquids and gases. The movement pattern in a fluid caused by temperature differences within the fluid. Convection current. In simple terms, a convection current is when warmer fluid rises and cooler fluid sinks, creating a circular flow. Imagine you're in a crowded elevator and everyone is trying to reach different floors. Just like people in an elevator move up and down to reach their desired levels, warm and cool parts of a fluid move in a similar pattern. As the fluid heats up, it rises, similar to people trying to get to higher floors, while cooler fluid sinks, akin to people heading to lower floors. This movement creates a continuous cycle, like an elevator's constant up and down motion, illustrating the convection currents caused by temperature differences within the fluid. The outermost layer of the atmosphere. Exosphere. The exosphere is the thin, outermost layer of Earth's atmosphere where air molecules are very sparse and can escape into space. Imagine you're at a crowded party, but you're standing near the exit where it's less packed and you can easily leave at any time. This scenario is similar to the exosphere, which is the outermost layer of Earth's atmosphere where air molecules are sparse and can drift away into space. Just as you are on the edge of the party, ready to step out into the open, molecules in the exosphere are loosely bound and can escape Earth's gravitational pull, illustrating the transitional and less dense nature of this atmospheric layer. The layer of Earth's atmosphere above the stratosphere but below the thermosphere. Mesosphere. The mesosphere is a layer where meteors burn up, creating shooting stars visible from Earth. Imagine you're at a crowded concert, trying to find your friends who are standing in the middle of the crowd. Just like the concert crowd acts as a barrier you need to navigate through to reach your friends, the mesosphere is a middle layer of Earth's atmosphere that separates the stratosphere below from the thermosphere above. In this analogy, the concert crowd is the mesosphere, acting as a transitional zone you must pass through to move from the lower, quieter area, stratosphere, to the higher, more active area, thermosphere, much like how sound and atmospheric phenomena transition through these layers in the sky. A molecule composed of 3 oxygen atoms, it blocks UV rays. Ozone is a gas in the Earth's atmosphere that helps protect us from the sun's harmful ultraviolet radiation. Imagine you're at the beach on a hot summer day and you find a large umbrella to protect you from the sun's intense rays. Just like that umbrella shields you from getting sunburned, the ozone layer acts as Earth's umbrella, blocking harmful ultraviolet UV rays from the sun. In this analogy, the umbrella represents the ozone molecule composed of 3 oxygen atoms, creating a protective barrier that prevents UV rays from reaching and damaging the skin, much like how the ozone layer protects all life on Earth. The transfer of energy by electromagnetic waves, it does not require matter. Radiation is energy, traveling through space as waves or particles. Imagine you're trying to get someone's attention across a crowded room without being able to physically approach them. Just like you might wave your hands or use a flashlight to signal your presence from a distance, radiation transfers energy through electromagnetic waves without needing a medium like air or solid objects. In both cases, whether it's your signal reaching the other person or energy moving through electromagnetic waves, there's no need for direct contact or a physical intermediary. It's all about transmitting a message or energy across space. The uppermost layer of Earth's atmosphere. Thermosphere. The thermosphere is a layer of Earth's atmosphere where temperatures can get very high due to the absorption of solar radiation. Imagine trying to keep warm on a chilly night with just a thin blanket. This situation is similar to how the thermosphere functions, as it's the uppermost layer of Earth's atmosphere where temperatures can soar, but the air is so thin that it doesn't feel hot. Just as the thin blanket provides minimal insulation despite the potential warmth, the thermosphere contains very few air molecules, meaning even though it's heated by the sun, the sparse air can't effectively transfer heat to make you feel warm. The thermal energy transferred from a warmer object to a cooler object. Heat. Heat is the energy that moves from something hot to something cold. Imagine you're at a crowded party and one friend is monopolizing the conversation, talking nonstop while others barely get a word in. This scenario is similar to how thermal energy flows from a warmer object to a cooler object as the warm object dominates by transferring its energy to the cooler one. Just as the talkative friend transfers their conversation to a quieter group, resulting in a more balanced discussion. Thermal energy moves from the warmer object to the cooler one until both are at the same temperature, achieving equilibrium. How hot or cold something is, it is determined by the kinetic energy of its particles. Temperature. Temperature is a measure of how fast the particles in a substance are moving. Imagine you're stuck in traffic, and the flow of cars seems to dictate how long your journey will take. This situation is similar to how the temperature of an object is determined by the speed and movement of its particles. Just as the density and speed of cars influence how quickly you can reach your destination, the kinetic energy of particles determines whether an object feels hot or cold. Faster moving particles in a material mean higher kinetic energy and a higher temperature, much like a faster traffic flow means a quicker trip. A layer of electrically charged particles in the thermosphere. Ionosphere. The ionosphere is a part of Earth's atmosphere that contains charged particles and reflects radio waves, allowing for long-distance communication. Imagine you're at a concert trying to hear your favorite song, but the chatter of the crowd makes it difficult to catch every note. This situation is similar to how radio signals, which are like the sound waves of your song, travel through the ionosphere, a layer filled with electrically charged particles that can scatter and refract these signals. Just as the crowd's noise can affect how you hear the music, the ionosphere's charged particles influence how radio signals are transmitted and received on Earth, with both scenarios involving interference that alters the clarity of communication. The flow of air from land to sea. Land breeze. A land breeze is when cooler air from the land moves toward the sea, usually at night, due to the temperature difference between the land and water. Imagine you're at a crowded concert and everyone decides to leave at once, creating a rush towards the exit. This is similar to how air moves from land to sea during a land breeze. Just as people flow from the crowded space, land, to the open area, sea, to find balance and comfort, cooler and denser air from the land moves towards the warmer, less dense air over the sea, seeking equilibrium. The flow of air from the sea to land in the daytime. Sea breeze. A sea breeze is a cool wind from the ocean that moves toward the land when the sun heats up the land faster than the water. Imagine you're at a crowded concert and everyone rushes towards the stage when the main act comes on. This movement is similar to how a sea breeze forms as air moves from the cooler sea towards the warmer land during the day. Just like the concertgoers moving towards the excitement, the cooler air from the sea rushes in to replace the warm, rising air over the land, creating a flow from sea to land. The weight of the air pressing down on a surface. Air pressure. Air pressure is the force exerted by the weight of air molecules on a surface. Imagine you're at a crowded concert, trying to move through a dense crowd to reach the front. Just as each person in the crowd is exerting a force against you, making it difficult to move, air pressure is the weight of air molecules pressing down on a surface. In both situations, the force exerted by each individual, whether a person or an air molecule, accumulates to create significant pressure, making it challenging to move forward, or, in the case of air pressure, to lift against it. The release of harmful materials into the atmosphere by human and natural activity. Air pollution. Air pollution is when harmful substances like gases, smoke, or chemicals are added to the air we breathe, making it dirty and unsafe. Imagine you're trying to enjoy a quiet evening at home, but your neighbor's loud music keeps disrupting your peace. Just like the loud music invades your personal space and affects your comfort, air pollution involves harmful substances being released into the atmosphere, disrupting the natural balance and affecting our health. In this analogy, the neighbor's loud music represents the pollutants. Your peaceful home environment symbolizes the atmosphere, and the disturbance to your peace parallels the adverse impacts of air pollution on our environment and well-being. The height above sea level. Altitude. Altitude is how high something is above the Earth's sea level. Imagine trying to stack a pile of books on a wobbly table, aiming to reach a specific height without having them topple over. Just like measuring how high the stack goes from the floor to the top book, altitude measures how high a point is above sea level. In both cases, whether you're measuring the height of a book stack or determining altitude, you're assessing the vertical distance from a baseline level, be it the floor or sea level, to a desired height. An object's mass per unit volume. Density. Density is how much stuff is packed into a certain amount of space. Imagine trying to pack a suitcase for a long trip and struggling to fit everything in. This is similar to the concept of density, where you're trying to fit as much mass, clothes, and items into a limited space, your suitcase. Just as packing more items into the same suitcase makes it feel heavier and more compact, increasing the mass within a given volume increases an object's density, showing how tightly matter is packed together. Gray-brown air pollution made up of chemicals. Smog. Smog is a type of air pollution caused by the interaction of sunlight with pollutants from vehicles and industries. Imagine you're trying to clean out your messy room, but every time you think you've organized one section, you realize you've just shifted the clutter to another corner. This is similar to how smog forms in the atmosphere. Different pollutants from cars, factories, and other sources mix together, creating a new kind of clutter in the air. Just as moving items around in your room doesn't really solve the mess. The combination of chemicals in the air doesn't just disperse harmlessly, but instead creates a complicated mix of pollutants that obscure visibility and harm health, much like the chaotic state of your reorganized room. All the water on Earth. Hydrosphere. The hydrosphere includes all the water on Earth's surface, underground, and in the atmosphere. Imagine trying to manage your household budget, where you need to keep track of all your expenses, from rent to groceries to entertainment. This is similar to the concept of the Earth's hydrosphere, where the planet manages all its water, from oceans and rivers to glaciers and atmospheric moisture. Just like your budget consists of different categories of spending, the hydrosphere encompasses all forms of water, each playing a crucial role in maintaining balance. Whether it's the vast ocean of rent or the raindrop of a morning coffee. A wave of electric and magnetic energy that can travel through matter or a vacuum like X-rays. Electromagnetic waves are invisible waves of energy that include light, radio, and X-rays traveling through space. Imagine trying to carry a conversation with a friend in a crowded room filled with noise. Just as your voice needs to navigate through the chatter to reach your friend, electromagnetic waves, like X-rays, travel through different mediums or even a vacuum to deliver energy. The way your voice cuts through the noise, sometimes bouncing off walls or weaving through gaps in the crowd, is similar to how electromagnetic waves propagate through space, carrying energy across distances regardless of the surrounding environment. An instrument that measures wind speed, anemometer. An anemometer is a device used to measure how fast the wind is blowing. Imagine you're trying to gauge how busy a restaurant is just by driving past it. This is similar to how an anemometer measures wind speed by observing how fast the wind causes its cups or blades to spin. Just as the number of cars in the parking lot can help you estimate how crowded the restaurant might be, the speed at which the anemometer's components rotate provides information about the wind's velocity. An instrument that measures air pressure. Barometer. A barometer is a tool used to determine atmospheric pressure, helping forecast weather changes. Imagine you're trying to determine if it's going to rain by feeling the heaviness of the air around you. This is similar to how a barometer works, as it measures the weight or pressure of the air. Just as you might feel the air getting heavier before a storm, a barometer detects changes in air pressure to predict weather patterns, with the air's weight acting as a clue, much like the way your senses perceive the heaviness in the atmosphere. An instrument that measures temperature. Thermometer. A thermometer is a device used to measure how hot or cold something is. Imagine trying to decide what to wear based on the weather outside. Just as you check the sky and feel the air to gauge if a jacket is needed, a thermometer measures temperature by responding to changes in its environment. The thermometer acts like your senses, detecting how hot or cold it is, and then provides a clear readout, just as you make a decision based on your observations.